Welcome to the OpenNMS 101 again, Module 8, Part A, Service Assurance Preparation. This module will create a Linux script tied to SNMP through an SNMP extension. This means that the script and its output are available through SNMP. This will be demonstrated. OpenNMS will refer to the SNMP extension as a service. A service detector will be created in OpenNMS. After the service is detected, the process of monitoring the service will be explained. Monitoring is accomplished through polling. In OpenNMS, polling is configured in the file poller-configuration.xml. The module will conclude with a discussion of scheduled outages. From the manual page for snmpd.conf, one of the features of the SNMP agent in Linux is to extend its own functionality, not just through additional MIB files, but also by executing external applications through the extend directive. SNMP extend provides two results tables per extend directive, each assigned its own MIB root. The extend directive takes a number of arguments. The cache type is used to cache the result of the execution for time seconds. This can be helpful if the extension is repeatedly used in a brief period of time. This is optional. A specific shell can be designated in which to execute the extension. This is optional. The MIB OID is optional and moves the root of the output tables. The name, prog, and args indicate the name of the extension, the program or script to be executed, and the arguments to the program or script, if any. These are required, save for the argument. The first output table is ns extend output 1 table. It has the OID shown. The table contains the first line of output, all of the output as a single string, the number of lines that the program or script outputs, and the exit status of the program or script. The second table is ns extend output 2 table. It has the OID shown. The table prints each line of output as a separate MIB object. The script will be placed in /user/local/bin and named tutorial.sh. The script will be owned by OpenNMS and the file permissions will be 755. The script will execute in the user bin bash shell. The script will echo OK. The script will be run at the command line to demonstrate that it works as expected. To extend SNMP, edit /etc/snmp/snmpd.conf. Toward the bottom, add the line extend tutorial monitor /user/local/bin/tutorial.sh. Note that there are no args to the script. The name of the extension is tutorial monitor. To create the shell script, create a file /user/local/bin/tutorial.sh. Change the ownership of the file to OpenNMS. Change the permissions of the file so that anyone can read and execute it, but only OpenNMS can edit it. Linux permissions allow root to edit this file. Edit tutorial.sh and set it to run in the bash shell. The only other line in the file prints, echoes, the word OK. Save and close the file. Execute the file to verify that it works. Add the extension to SNMP by editing the file /etc/snmp/snmpd.conf. Scroll down to the bottom of the file and add extend tutorial monitor /user/local/bin/tutorial.sh. Save and close the file. Use system control restart snmpd.service to restart the SNMP agent. The extension is ready for testing. Begin by performing an SNMP walk against ns extend output 1 table. Recall that the SNMP agent is configured to use SNMP v3. Breaking down the output, the first line is ns extend output 1 line, the first line of output, which is OK. The next line is ns extend output full, which would be all the lines of the output, but there is only one line of output, so the value matches the first line OK. The next line, extend out num lines, is the number of lines output, which is 1. The final line is the exit code of the script, ns extend result, which is 0. Perform an SNMP walk against the ns extend output 2 table. Only one line is output, ns extend outline dot 1, the string OK. It might be interesting to change the script a bit so that it outputs multiple lines. Edit tutorial.sh so that it outputs 3 lines, 1, blue, and OK. Save and close the file. Reperform the SNMP walk on ns extend output 1 table. There are some differences. ns extend output full is 1, blue, and OK. All the lines are in one OID, and the ns extend out num lines is 3. Now perform the SNMP walk against ns extend output 2 table, and note that each output line of the script is assigned to a different OID. The ns extend output 2 table would be easier to work with if multiple lines of data were output by the script. As such, it will be used in this module. Edit tutorial.sh so that it only outputs one line of text. OK? Save and close the file. Rerun SNMP walk against ns extend output 2 table to verify it still works. Rerun SNMP walk against ns extend output 2 table, but force the output OID to remain numeric. The OID is fairly long. Part of the OID is the ASCII equivalent of tutorial monitor. The .1 is still at the end of the OID. OpenNMS detectors are discussed in the Horizon reference documentation under Provisioning Detectors. 2 common configuration parameters are service name, which should be as specific as possible, and timeout, which defaults to 2 seconds. As tutorial monitor is an SNMP extension, it follows that the detector is an SNMP detector. The documentation for SNMP detectors is found in the Horizon reference documentation under Provisioning Detectors SNMP. The only required parameter is the OID. There is an example of creating a detector for an SNMP scalar value. All that is needed is the name and the OID. Copy the OID. From OpenNMS, go to Admin Configuration, Manage Provisioning Requisitions. Click on the pencil icon on the Self-Monitor line to edit that requisition. Click on Edit Definition. Click on Add Detector. The detector name is going to be the service name, so be conscious of the name entered. Do not use spaces in the detector name. This module will use tutorial-monitor. The class, in this case, is SNMP. Type SNMP in the drop-down text field and click on SNMP. The exact class is SNMP Detector. Per the documentation, add an OID parameter, and the value of the OID is the value copied at the command line, which includes the name of the SNMP extension, Tutorial Monitor. This is sufficient for detection purposes. FYI, since this detector makes use of SNMP, OpenNMS must be configured with the proper authentication to SNMP on the network element. This was covered in Module 6. Save the detector configuration. Now Tutorial Monitor is one of the detectors in the requisition. Click Save and Return. Click on Synchronize and rescan all nodes. Click on Info Nodes. Scroll down and observe that the service Tutorial Monitor has been detected on both 127 192.0.0.1 and 192.168.159.105 interfaces. There are events indicating the tutorial monitor service has been detected. The tutorial monitoring service has been detected, but it is not being monitored. In order to monitor a service, OpenNMS must poll that service. Up next, Module 8 continues with Part B, OpenNMS polling.